that will be the purpose will be solved for this FDP, and that will be followed by next my some I will wanted to give us some lecture on the introduction to the finite element method in engineering applications. So with this, I will close all this topic for this at least today's session, and maybe in the tomorrow will be the one more expert will come and give you more idea about this materials of what is the advances in the materials. Okay, so with this I will start the today's session with this introduction. Okay, first, okay, when we say the engineering material, what is engineering material? First we should know about it, right? So in this case, just we can able to see the definition is it is refers to a group of minerals that are used for constructing or manufacturing of structures or machines and its components. That is the overall basic definition of an engineering material. If is, but why we required for this more importance is, if you know, see here, whenever we have a loading, because everybody engineers always talk about the loading and stresses and all the stuff. So at the end of the day, we have to check whether the manufactured material is withstand for the given loading. That is the end of the goal of any engineer, right? So based on that, we have to choose our material which one is suitable for a particular case. That is the overall definition of engineering material. If you see again, engineering materials can be classified into main classification into metallic minerals and non-metallic, right? So in the again metallic, if you see here, they are ferrous, non-ferrous, and again if you non-metallic, again organic and inorganic. And again come to the ferrous materials, again subdivided into steels, cast iron, and again non-ferrous, again subdivided into, we know all this, all aluminum, copper, magnesium, tin, zinc, lead. Everybody is this, no, just I am not concentrating more on this, and just given topic as everybody should know what is the organic and what is inorganic, just example. So I will go further on this. And yes, here is the more I am interested to get more knowledge on this type of a properties, because at the end of the day, we are engineers always talk about the how much the properties it is suitable as a property. So if you entire mechanical, if you see that properties of mechanical properties, these are the main properties generally useful for any type of the field, either construction or the machine and mechanical or chemical, anywhere in the universe we can able to talk about these mechanical properties mainly. Some few other examples are there, but there will not much importance. This is the overall properties of any material. If you see here, just I will read quickly: strength, elasticity, stiffness, flexibility, plasticity, ductility, malleability, toughness, resilience, hardness, brittleness, creep, fatigue, and machinability. So as you know, everybody have heard this all these material properties, but when we can able to get more interesting is we should know the meaning of this exact word, right? So this was the main important. So I will concentrate always in this type of the lectures, because just I wanted to give a few examples. If you see, because once what is the engineer, because I am basically from the industrial background, so what the industry expects who are graduating from the institute, educational institute, is they should have some concepts and skills right from the engineering, what he will learn from the engineering. So that's what we expect, as not only we, the industry expects, right? So for that, as a teacher, our main goal to educate the students in such a way that they can be useful for immediately after the graduation to the industry. That is the end of the goal of every student, right? So as a teacher, always we have to be go in this approach, definitely we can get a produce a, I can say, is a good step for students, rather than if you're going, if you see nowadays everybody is, most of them, I'm not saying anybody, even though it is graduated, they're no job, but they are thinking that there is no jobs, that's why I'm not getting. That is entirely wrong. There are a lot of jobs and scopes in this country or everywhere, but the thing is, we are not having the skills, and the students who are projecting and not having the skills that will be give as a output, some output to the industry, that's why there nobody coming forward. For such students, I'm not telling about the all such students, but the same thing if you compare the IITs, so even they're also not having experience, but everybody will recruit. But why? What is the reason? What is the difference between IITs and our institutions, normal institutions? That we have to think in that way, because the everything, if a brand IIT is there, they will think, obviously they will have a good stuff in there, they will learn something good from their experienced faculty, which will be they train the students, which will be useful for the industry. So that is the main goal of it. So why can't we also can able to produce a good engineers like IITs and NITs? We can. Only thing is we not give that much priority to the this type of learning to the students. So let's say at least I have started in the way thinking. Obviously, if we can really teacher wants, definitely he can give a good output rather than a normal teaching, right? So, and I will tell you in a few examples what generally what we have to give as a teacher to the students. See, just in practical way, generally every human having the two brains, one is the left brain, one is the right brain. So at a time what we can able to see is whatever the theory what you are telling, or formulas or definitions, to remembering that, always our left brain will work, it will be stored in the left brain. Suppose right brain, what it will say, right, right brain always wants the what visualization and understanding of the topic, that will goes to the right brain, right? So always as a teacher we have to be give the more work to the students right brain, not the left brain. Left brain formulas everywhere they can able to get from their from their whatever the textbooks or notes or somewhere, but always industry and a good engineer, always the things have to be used his right brain also effectively rather than the left brain. So that's what we have to be give. So such that the left brain, as I said, it is a visualization. If we can able to visualize, support to the visualization of the students, they will enjoy the learning. Always it will be useful for their future. So on that basic concept, I always give the lecture to give the work to the students' right brain. I will give you some of the examples, then it will be used that you can understand what I am exactly telling. Okay, so with this again, I will again go to the exact topic. It is what is today's topic, and now I wanted to just use the right brain for taking example of this properties of a materials. Let's see. See, first I would like to give the definition of the strength. The strength definition, as I just said, our left brain always taking of the definitions or the formulas and all. So everybody knows the strength. It is defined as the ability to withstand with an external load without failure. That everybody knows that. But when we say the students strength and also the stiffness, there will be little confusion. So always that's why then we have to give the properly support to the students such a way that their right brain works properly. See, for example, if you can able to see some examples and some visualization, then obviously their right brain start on working. So here if the same thing, instead of the giving the definitions, if you gave some examples in this type of, for example, here it is, see, I have presented a small example such that they exactly visualize the what is the strength is. So here it is, I said it is a difficult to bend it but easy to break it. I have shown this as a glass. If I say see this thing, obviously we can say the strength is low, stiffness is high for the glass material, right? So again, if you compare the another topic, Suppose you have shown something example as a spring. So what is the spring per property? It is easy to compress it, but difficult to break it. Right? So in this case, we know compare the strength and stiffness. Due to this definition, strength will be high and stiffness is low. Right? So then if you see, the student will understand this as a visualization mind. Obviously, okay, what is the strength? What is the stiffness? He will be more enjoy the learning. Right? So this is one of the same thing. We will do some other properties. And if you see here, next topic is the properties elasticity. Everybody knows this is not a difficult thing. Everybody knows elasticity. It is defined as the ability of a material to return its original position after removal of loading. In other words, it is the ability to stretch. Simply, we can call it as ability to stretch. This everybody knows. No need to explain anything. But if again give the another property flexibility, then we will tell the students to compare this. Then again, their right brain will stop working. So that's why at least we have to be compare the side by side. Obviously, their right brain will keep on working the visualization. We see the same thing I have seen here, shown here. Strain is the taking place in elastic limit is known as the flexibility. Otherwise, ability to bend. So here is ability to the stretch. Here ability to the bend. That is the difference between the elasticity and flexibility. So what I mean to say, give the proper examples, then obviously their right brain keep on working. So that will be helpful to use their gain some visualization. At the end of the day, engineering is nothing but visualization. Okay, then I can proceed further step. Yeah, here, ductility, yes. This is also very important property of a material, especially if you can see all these engineering applications, we can use the ductility, brittle. Many times we'll use that word. So, but we compare side by side, then we can get the more idea. So, as shown here, ductility is defined as the ability of a material to be pulled into the thin wire or a band. That is known as the ductility. Next, the brittleness. The material is said to be brittle if it fails without any plastic deformation. That okay, that is the definition anywhere, we can get anywhere. But our duty is we have to explain to the students such a way that their right brain should work. If you see here by examples, by showing the some sketches, they can able to see in the first case, we are applied a body is there, we are applied at a force. It is a tension force, whatever maybe. So now if you see that condition A, figure A, here it is failed in a horizontal path and suddenly. So if we compare to the B case, it is not suddenly happen, it will elongated something before it is failed. That we call it as a brittle, that is ductile failure, right? So if somebody will again will be confused by seeing this figure, always brittle failure will be the horizontal. No, that is a wrong assumption. It cannot be the horizontal. It may be horizontal sometimes, but that is not the exactly definition of a brittle and ductile. So brittle is nothing but it should be failed suddenly. It may be horizontal or it may be fail in an inclined way. But only thing is, before failure, it should not able to deform. That is the word, the brittle failure. So if you see that next brittle fracture in this figure, it is not failure in the horizontal failure mode, it is an inclinedly failed. But if you see the diameter of the rod, it is not anything changed before the failure. Whatever there is initially, it is the same at the after failure, at the time of the failure also. That type of failure we know as a brittle. But if you same compare with the ductility, see there will be the difference of the diameter at the time of failure. Initially it will be the big, and at the time of failure, if you see here, it will be little less diameter. That means what happened is it is failed before, at the time before the failure, it is elongated. That is the word that we can call it as a ductile. Okay, next I'll come to the toughness and hardness. Here also many students will get little confusion. What is the toughness? What is the hardness of a property? So here I can again explain in such a way that they can able to use their right brain. So this is here, toughness is defined as the ability of a material to absorb some energy during the plastic deformation up to the fracture. Please remember, it is up to the fracture. Once the fracture is over, there is no toughness. We cannot tell the toughness. Up to that failure, we suppose the material try to bend, we can able to mend that we how much is able to absorb the energy. We call it as a toughness. And its hardness. What is the hardness? The hardness is nothing but is the ability of a material to withstand penetration. Please see there is a difference between the toughness and hardness. So if you see the sketch here, where again somebody is trying to penetrate by applying some force. If it is not properly penetrate, we call it as a very hard material. Suppose it easily penetrates, the hardness is less. So this was the job of the things. So okay, next I think about the another the malleability, resilience, and machinability. So what is these properties? We should use that our right brain whenever you see this type of the definitions. This is a word, resilience and machinability. So in that way, I have just shown some examples of the figures so that our right brain will easily work out. So in this case, it is defined as the malleability is defined as the material to be flattened into the very thin sheets without cracking. So please remember, without cracking, how much thin we can able to do, that more we'll call it as a more malleability. For example, if you see the gold at our shin, even though it is a solid in material, but if you can able to be make in a very thin sheets of the plates of the gold. As we know, almost many of you are seen, some of you use the golden saris, right? It's very interesting. For if you wanted to make the sari with the gold, you can imagine how much thin we have to make. So that is a possibility is there. So that's why, because it is a highly malleable metal. So that is the thing. Next, resilience. This is also very important property, especially we can use in vibrations and all. So it is the capacity of a material to absorb energy when within the elastic limit. Please again read the carefully for the entire definition. Many students just by hearting the definition, then there will be no use. To understand the definition, obviously we'll get enjoy more learning in the skills. So here if I see elastic limit, so what is happen? Suppose there is a pendulum is there. We have given some energy. We keep on moving. So otherwise, if you apply the spring, apply the force, it will be resilience will be happen. But if you keep the plastic, it will be again come back to original position. We cannot call it as a resilience. Please up to the elastic limit. Please remember. Next, another thing is machinability. Then what is the machinability? So machinability is nothing but if any material can able to mold in a required shape, that is required. Otherwise, we cannot able to use that metal. So in that way, suppose if you take any material, if we can easily able to machinability. Suppose if we can able to make the threads, or we can mold in a particular shape. In that case, obviously, this machinability property will work out, right? So another example I will say, this is a very important thing. This is the creep and fatigue. So creep is nothing but the material in service are often exposed to the different types of continuous forces. For example, it is a temperature. Suppose some machinery we are kept outside of our store. So it is continuously exposed to the weather. So what happens is after some years, that function of the material, that property will lose their significance. That we call it as a creep, right? So but please remember, it we cannot able to see immediately within this our naked eye. It will be possible only we can see after a huge lifespan, right? That is the creep. Next we'll come back to the fatigue. What is the fatigue is? So if you see the fatigue, now if you see many machines will use the mechanical mainly machinery, right? So it is continuously keep on working these machines. What happens is the vibrations will continuously develops, keep on are working. After some stage, the material will lose their property. So that we call it as the fatigue. That is nothing but continuously lose when there is a body is subjected to continuous loading or cyclic loading. At the end of the one few years, that property of this actually required that will be loose. That we call it as a fatigue. For example, if you see here, I have shown in a tree for the creep. So we will take in a small branch of a tree. I applied some load, whatever maybe, of 50 kgs or 100 kgs, whatever that is example. So first day we cannot able to see any difference on this deformation. But if you see after 1 week, this we can see the small difference. It will be little bit deflected or deformed downwards. And then after 1 year, 2 years, we can able to see further deformation at the, after some time. That is why it is happening. This is due to the creep property, right? So this was the practical examples of the creep. Okay, so these are the major properties what we have to be learn and understand the basic definitions. When we'll remember, whenever we say here that name, toughness, or what are the properties are there, we should be use our right brain, then we can able to do the problems easily. So that was the one main concept of I am explaining here in this use of the. So the same theory you can able to apply in the students. Obviously they will enjoy the learning. Okay, next I will come back for the actual applications of this material. Right, these materials, end of the day, we have to use somewhere apply. Right, the applications we know in entire engineering, it is the application. Without applications, there is no engineering at all. So there are a lot of engineering fields are there. So everywhere we will use this material. So that's why there is a very significant use of these materials. Each field should be know at least basic idea of the materials, either irrespective of the civil engineering, mechanical, chemical, everywhere. Every engineer should have a basic idea of this engineering material. So based on that, I think this FDP course is conducted by the organizers Vignan. So I think that will be the useful to you at least end of the all the 4-5 lectures of this series. But if user maybe the next tomorrow, maybe some of more experts will give the more idea of these materials and what are the new techniques also they will going to explain. Okay, for at least for today's my session, I just wanted to, till now I have given the basic introduction of the materials and what are their properties and what are the application at different fields. So I have just taken a one example of that application is the finite element method. So in that I just give another half an hour. I will going to continue about this application, but is indirectly related to the material only. Without material, we cannot able to go for the application. Okay. So again, we can see again come back from the basic thing. As everybody, we are all engineers, right? Engineers, everybody. That means we have done that BTech or MTech or PhD, whatever maybe, we call it as engineers. Even though if you go to any field or you can say industry or in the as a teaching profession, but basically we are all engineers. So first we should know, not we, I can say the students' point of view, students can able to know what is the engineering is. Then, but if you see many students, even though they passed out and go from out of the institution, but somebody will ask what is engineering, they will be blank. They have no idea what is they learned. But at least the first, as a teacher, we have to give something what is their definition of engineering. So here I have just defined as a practical way, engineering is a scientific understanding of a natural world by using it to invent and design and build the things to solve the problems and achieve practical goals. This is what engineering is, right? So always end of the day, we have to solve the practical problems. That is the role of the engineer. So in that way, this is the engineering. But if you see, without engineering, this entire technology and world is not there. The engineering will build the technology, right? So in this modern world, I think without the engineering, there is technology, there is nothing is there. So that is why I say everybody should be give the importance to the field of engineering. So as a teacher, it is in our hand to produce good engineers. So that is the more responsibility we should have take. But in this world, entire there are the two professions will get a more responsibility. One is the doctors, one another is a we, that is engineer, that is a teacher, right? So remaining all professions are there. I'm not talk about anything bad about them, that is a fine. but if you cannot able to do well in that particular profession, you can get the loss. But in these two professions, if you do mistake also, obviously it is affected by the others. So in that way, that's why said these two are the having the more importance in this society. So as a part of this profession, we have to be give think in this mind. So we are not only improving ourselves, we are having improving the others. So always, that's why always try to get more knowledge on this one, any topic, whatever your own field of engineering, that will be useful to the future engineers. That is the major role of any teacher. So with that, anything, but unfortunately, if you see, everybody can able to say, if in this field, always asks, judge, not ask, by judge the person by having the experience. So if you apply, if you go to any institute, they will first check how many years of experience you have. If you have how many years of experience you have, so that will be first impression if you ask anybody. But I don't think so, but this is my personal opinion, it may be wrong, but this is not right correct. So end of the day, if you see, the person is can be is skilled or not for that profession, that will be really matters. It is not a matter of experience and all, right? So because if you see that the same example I said, if you go to not only the teaching field, if you go to the industry, everybody asks how many experience you have. They will judge based on their experience. Suppose if you have a 1 or 2 year experience, they will immediately use their right brain to think, okay, his person is not good, is average. Suppose if you have a person having a 20 years experience, immediately their right brain will think, oh, 20 years experience, that means he is very good. But okay, also it's somewhere I can say it is fine, but is entirely you can judge the person only to field of the experience. For example, if you see the IITians, so even though if you are not experienced, the industry will take and give the how much salaries, in the lakhs of salaries they will give. But if you compare this way, why this person is not having any experience, why these companies are recruiting with a paying lot? In that way they are thinking different way. So what I said, my opinion is the same, but I'm sorry if anybody having the not more experience is, but obviously it is good we have the both. Obviously experience with the skills, obviously it will be the more advantage. But just this is the example. Again I am going further, I think I am deviating for the subject, and again I am going for the regular topic of this finite element method. And once we understand the engineering, what is the engineering, and if you can go further work on this field of engineering, here I have shared some figures, general figures here, to use our right brain should work. If you simply definition, only our left brain works and there is no use. So always my lectures and my teaching will be always to use the students to use their right brain. So if you see for already defined the engineering, I will explain what is engineering in the form of a example. If you see here in this screen, we can see that some crane is there, arrangement is there, and there's some, I can say some weight or pipes is there, they're lifting. But here where the engineering is using, is they can able to do any mathematician to work in this? I have say absolutely no. Here we can use our engineering knowledge to be work out this practical problem. Here the problem is we have to lift the pipe. So and end of that, so that is the final goal. So engineers, what the engineers will do is they can do, if you are not an engineering, they can able to lift from anywhere. That is possible, but if you see, if you do that, obviously the rotation will takes place and it will create the additional moment when including this weight and other movement. Additional existing is there, with unnecessarily we are creating, though they are creating more additional moment to make the job tough. So that's where engineering will come. If engineering will come, they will think, okay, this is the material is there, we have to be lift in a proper way such that we cannot able to get additional moment, additional load while lifting. Then what we will do is, engineers, just we have to find the centroid location or center of gravity of that material, so that from there we can easily able to lift, so that may not able to create any rotational or additional moment for this application of this case. That's what engineering is field. Just this is I said one of the example of this is, if you come to the another picture, there is a cylinder. I can say I cannot have the cylinder, but it is a pressure vessel. Obviously the shape is the cylinder. So obviously if you see the non-technical person or is a non-engineer will always say it is a cylinder, but we know that it is a cylinder, but there is a particular name of this pressure vessel, right? So we read all this stuff in the store, but here also we see different components are there here in this one cylinder. But these use, we know as engineers, we need each material component in the cylinder have a particular use. So that's what engineering will do this. So how to we can able to do solve this problem, that if in case of a find the stresses, not the stresses, we can able to find the material that I'm going to be take in another few future lectures, I can say. So here again, I'll come back to the exactly to the topic of the finite element method. Okay, so before again I'm going to the finite element method, so we should know as an engineer, we are always solve the practical problems, right? So for the practical problems also, there are many ways to solve, right? So for example, if you see any problem, there are the majorly three types of problem solving approaches are there. One is the analytical method, then another way we call it as simply word as a hand calculations. Next one is the numerical techniques, and the third one is the experimental method, or another name is physical testing. So if you wanted to solve any problem in this universe, any of this one method should be applied. Okay, so but as I said, just simply I saying the definitions, our right brain should not have that work. I wanted to give little work to the right brain. So in that case, again, if you see the I define more accurately the what is the analytical method. We taking a small example. If I take an example, if there is a family, there are 4 persons with having the different age groups. There are ages groups are 1 year, 2 years, some is 27, and one is 30 years. So now my task in this problem is, I wanted to find the what is the average age of these all four. That is the task. Suppose this is that. So in this we can directly, without asking, going for it directly, we can do all the add and divided average. We can easily do with your hand calculations. It is easy. So if we add all four divided by total four, we will get that average. So this type of approach, we call it as the analytical approach. But in this practical cases everywhere, we cannot able, this is not that much easy to like what you do in the analytical methods and health calculations. In engineering, a lot of complicated problems are there, especially the 3D body problems. It is not easy as this simply by doing hand calculations. There, the need for the numerical method. For example, if you see here, I have given a one mathematical equation, f of x is equal to, and some sigma n is equal to 0 to infinity, and an x to the power of minus c to the power of n is equal to a naught plus so on, a plus x minus c plus so on. This is not a fixed problem. It is infinite problem. So it is nowhere we can able to solve this by hand calculation or analytical methods. So in this type of the problems, we can only the problems we can able to solve it as a numerical method. So numerical method, what is that numerical method? Please remember, this is not the exact method. The answer will not get the exact at all. But there is no other solution to get. We have to follow some method, right? So in that case, we have to go this numerical method. So now I am going to tell the example of a numerical method is our finite element method. And I will come back that again. I will just go to the another type of the method, experimental method. As we know, this is the another name is the physical testing. As everybody know, now we are facing the very big crisis of this COVID-19. So here, suppose this is also we wanted to come out of this situation, right? Dangerous situation. So this is also one of the problem, right? In this problem, suppose if you wanted to go working the analytical methods and numerical methods, it may not work. It's not possible at all. So in such cases, we have to be go another method. We call it as the experimental method. So what now the scientists are doing, that is the finding the vaccination. That is their problem solving. They have to solve that problem now. So all over the world now is working on that. So finding the vaccination of COVID-19. So that is the example I have taken. This is the experimental method. But okay, in my present next lecture, coming lecture will be the only on the analytical method. Now we got overall idea of this entire problem. Any problem in this world, we can able to solve any of this method. Based on the complicated of the problem, we can choose any method. Okay. And now I just wanted to little bit comparison between analytical versus as a numerical analysis, right? Analysis. So here if you see, I'm taking a one small equation of mathematical equation. Find the minimum of y is equal to x square minus 3x plus 2. This is the one problem. It may be mathematical or engineering problem. What are the type of the problem is, our goal is now we have to solve it. So this is a simple problem. Then we can able to do by simply analytical method. This is possible in this case. But suppose if the same problem, if you wanted to have do it the analytical method, what I am going to tell you in the maybe next slides about the finite element method. So this is, as I said, this is the analytical method. How this analytical problem will be solved in the simple equation is this is the nothing but what we have to do is every reason we have to be to take in some fine divisions. That's what the finite element method and the numerical method is. So entire we know the range is 1 to x is equal to 1 to 2, but y is equal to again 0. So x range is 1 to 2. Again that divide that equation into number of parts. That is every point to increment. And so, but please remember, our problem equation is such that we will get the answer in between 1.4 and 1.6. Right? That is the final answer. We know that we are getting the value of point minus 0.24 in this case, suppose. But we know that it is between 1.4 and 1.6. But since this is taken as the interval as a 0.2, we are getting this value. But if you reduce further, I mean to say further refine this problem, we will get a more accurate. So that I will tell you in this practical problem, you cannot, mathematical problem, you cannot able to that much visualize from your right brain, but I will explain in a one more example in the next slide. Then you can get more understanding what is the finite element method, what is the advantage of this meshing. Okay, we'll see that. Okay, again, I mean, again, further, I can input getting more explanation on the numerical method. As we know, this is an approximation and fast solution for the mathematical problems, right? That is the goal of a numerical method, because we cannot able to solve this problem by normal analytical approach. We have to go for the numerical method, but we can a quick way. And again, but please remember, this is not the exact method. But since there is no option for us to find the solution, we will go this numerical method. But at the same time, we can say we can get more accurate result in this numerical method also. Exactly, if not equal to the final exact exact value, but nearly we can able to approach by using the numerical method with using different techniques. That is, we call it as in the finite method as the fine mesh technique. Right? Fine mesh techniques, what we will do is, as I discussed in the earlier slide, we will define more refinement. Obviously, we can able to approach very near to that point, then obviously we will get that more nearest realistic solution rather than as a broad way. Let's see, we will see that in another form of slides we can see. So please remember, somebody has a little confusion that FEM and FEA, obviously this is the meaning is the same. Finite element method is nothing but a finite element analysis, because end of the day we are doing the analysis. So again, I will like you to come little idea when I say the analysis. The students should, again, they have to use their right brain. What is the analysis? So instead of simply analysis, there is no use. So what is the analysis means? Suppose if you know that any body is having some external load acting on it, obviously it will be respond. Right? Response means in the form of a deformation or the stress or the strain, anything. So this is the response will happen. So but if you see, we cannot able to see or visualize all the responses of a body due to the external loading. So now our target is, we have to check how this body is responding due to the applied loading. That is then call it as a analysis. So in this analysis, we can check, we will different ways of doing this analysis. We can use the computer techniques, and we can use some experimental techniques. All this is there, but at the end of the day, analysis is whenever we'll keep here that word analysis. Obviously, our right brain should work in a that, okay, analysis means we have to be doing the response of the structure or the material due to the loading. That is the analysis. Okay. Again, if you go to the history of the finite element method, when it is started and when the engineers has invented this technique, is we can able to just given a presentation here. Just this is just few words, nothing new in here. Everybody knows this. The finite element method, generally if you use in 60s, it is first mostly it is used in the aircraft industry, because this is the first that is the first application used this using this technique is in 1960s. The aircraft industry has mostly used in this finite element, and but later it is useful. But current everywhere, all the fields of even in the medicine also nowadays we are using this. I can say this is the finite element approach very effectively. So always it is a great future if this have no more understanding about the finite element method for all the engineers. Okay, so if you see here, the first finite element method is called used in the stress and plane stress analysis. Right? So plane stress analysis, when we say the plane stress, the students again will confuse on what is the plane stress. Why we call it as normally the stress. Stress, I already said, stress is also nothing but the forces which are developed internally in the material due to the external loading. That is, we call it as the stress. But we cannot able to visualize directly from our naked eye what is the behavior inside the body. That's why we will use this finite element method. The computers will solve the problem, and we can see the effect of the stresses in the form of the sketch. That's we normally will do in the finite element method. Stress diagrams only we will see, not the exactly behavior. That we will call it as a behavior. Okay, so here just I'm proceeding further on this one. The major what is the important thing in the finite element is the discretization. So what is discretization? When we will say that word discretization, obviously the new persons who are new to this subject, especially the students, they could not be confused what is that main discretization. So this is our duty as a teacher. We have to give more explanation to them to use their right brain. So in this way, I had defined as the discretization is nothing but divide the entire domain into number of smaller parts. That is a simple word. So if you say in this word, obviously they will remember this discretization and will there use their right brain. So again, I already discussed there are the different ways to discretize any element or any problem or any body, right? Discretization. If you wanted to more, I can say, more refined and more exact results, we have to be as defined as less as the less size as possible. But at the same time, we cannot able to do very micro sizes in the finite element method. As we will use the finite element method, as far as if we increase the meshing, we'll reduce the meshing size. We are giving that much problem complications to the system. So it has to create that many number of elemental stiffness matrices. So that will require the more space to the computer. So if you give that very fine refine, the computers also will sleep. It will not wake up another few hours. So then we cannot able to solve the problem. So there is an engineer, as we have to be think in a proper way. One is we have to solve the problem in a more accurately, at least more effectively, in a not like that. If you have one problem, if you wanted to solve for the 10 days to run the problem, then there is no use, right? So we have to be think as a finite element method, discretization should be such that it will be the accurate results. At the same time, it is the time concern, okay, for the analysis. Okay, with this next I will just explain now after the discretization, and we will come to the picture of the how the discretization will be taken place in a finite element method. So finite element method, as I said, we can apply any dimensional body, either a 1D or a 2D or a 3D. Anybody we can able to do, but if you keep on giving manually, if you wanted to calculate 3D figures, we will very difficult. So that's why we'll use algorithms and we'll use the computer programming to solve the 3D problem. But simple 1D 2D, we can do simple problems with the normally with our manual calculation also, if you know the exactly the concept of what it will do the finite element method. That is easy. I think you can students can able to learn. I'm not going to teach entire complicate the things now. Here just my presentation is overall idea of the finite element. Then it will be useful for further study. Maybe another experts will going to give in the coming classes on this finite element as for other applications. In that you can learn more on this finite element method. So as is presented here, there are the three types of methods, elements everywhere in the finite element. That is 1D or 2D or 3D. That generally 2D when we will use is the plane stress problem. Again, we should understand what is the plane stress problem is. Plane stress problem is nothing but we can visualize within a screen. Suppose we are seeing the screen. It is the plane stress problem because the thickness we cannot able to visualize. It will be in opposite direction. So many cases where it has a very less significance to the thickness. Suppose we take a plate, very thin plate. What are the thickness that may not govern the analysis that much? In that case, only we are interested in the area. In that case, we'll go for the plane stress problem. Instead of going for the solid problem, it will create more complicated things and the equation and the time. So that is the plane stress concept. If we really require and interested and we have already very accurate results, we have to go for the 3D dimensional problems. That is 3D meshing. Okay, just here I will just give a overall idea what will be the results if you use the refinement of the meshing. That is what my more concentrating at this topic now, right? So here, see, there is one body is there. We have applied the different external loading, and now we wanted to find the some stresses, that is response of the structure of this material by using this finite element method. That is the overall topic, overall concept of what I presented here. We see the loading is constant. Please remember, loading is constant. Material size is same, and its properties are the same. But only change is here. We are taking the different three problems and solving them in the three different messages. The thing. So here, first case we have used the finite element size as a 30 mm of each element. Second case I am using the 25, and the next case I am using the 10 mm of that size of the element. So the same force is not changing, and the loading is the same, and the area is the same, all properties of the same. But if you see the result here, we are getting the three different results after doing the analysis in the FEM. So if you see here, one first value, if you use the 30 mm mesh size, we are getting 1.048, what are the units maybe. And next one, if you use the 25 mm, it is we are getting 0.93 of that particular stress value. And the next few And if you see the next problem, we are reduced further into the 10 mm mesh size. We are getting 0.73. So if you see, we are having the different results. But at the end of the day, we are not changing any. The original material is the same, the loading is the same, but we are adding 3 levels. So these things students can able to understand why it is happening. Otherwise they can we can know there is no finite element and understanding of the finite. So I will give more clarity on that one, how the finite element will able to getting these values having different values. So I will explain in my next slide more, so that next our right brain will work in more work efficiently for the visualization point of view. So I have taken for a small example how the rainfall, how this finite element will give the stress results on the meshing. This is taken as a simple example without complicating the things. So if you see, so I have taken a one small element, planar element, as we considered this is a plane, and I wanted to know, so one point, what is the stress I am getting in a due to particular loading. So for this, what the finite elements will do is it will calculate all the forces and stresses at the all the nodes. It may be 4 nodes or 8 nodes, whatever the type of 2 nodes element. Worry about it, will always take the nodes as the reference. That is the main constant of the finite element. It will not bother about the inside portion, only the nodes. As a software that developed such that it will take the nodes is the main criteria. So if you take what the software will do here in this particular example is, so I have taken, suppose I am getting the stresses at this all the 4 nodes is the 5 units, so 5 units, 25 units at this node, and this needs 25 units, and here 45 units. So what the software will do is it will do the average of these 4 nodes, and it will present at this nearly center some area. It will not take a point, it will take some region. Always the stress will be shown not at a point. Please remember, in finite element always it will show it some region. So in this region, what it is calculated by the software is, for a using of this mesh size, we are getting, if you do all the 4 averages, 5 plus 25 plus 25 plus 45 divided by 4, we will get, sorry, we will get 25. The value at the point is the 25. So next, if we see, suppose I wanted to be more precise this value. I suppose some cases we require the more precise results. Some instruments we require the more exact stress, not like the average stress here. In that case, what we have to do is we have to make much smaller mesh for that body. So the same thing, I have taken the same example. I have taken as the further divided into the many number of other 4, I mean 4 into 4 mesh, that is the 16 small parts of the small, again the same body, right? In that case, what happens is, again the software will do the same. It will try to calculate the forces at every node. So it stress or force at every node. So here what will be a software know already, first will be the 5 and last point of the node is 25, and it will proportionally it will distribute the values to the other nodes which is connected. So that means since it is 5 to 25, equal proportions will be 10, 15, 20 in this direction. Again in this direction, if you see, again the proportions will be, equal proportions will be 5, 10, 15 and 20, right? Is further divided. Again, if you wanted to go to the, our interest is this at this point, because we will make this mesh finer to get the more exact result at this point where I have marked the red marking. So if you come to the now in this case, again the for this the finite element will do the same. The software will do the same. We'll take all the 4 averages of the 4 nodes and we'll give the results. The same thing here it is giving. If you see, it is giving 15 and 20, 20 and 25. Here all the 4 points of this particular element. Again, it will do the average of these 4 and it will present at the center. So that if you now in this case, if you do average of the 4, it will get 20. See, earlier we are got 25 of the same loading and the same material. Now due to the fine mesh, we are getting 20. So this was the difference of the fine meshing, the all the different fine mesh of this problem, right? So this was the basic idea of the finite element, how it will work. And obviously we can enjoy more if you get use our right brain properly. Then if any subject, many students will feel finite element is complicated. That is not like that. If you give the more work to the right brain, it is easy. It is not a difficult at all. So that's why I always say the students, don't directly blindly say any subject is tough and it's easy. That is not right. You are not trying, you are not utilizing your right brain for the particular subject properly. That's why you are feeling like that. So with this, I think overall I think almost the time is over. So I don't want to trouble you by extend my lecture. I have given only 1 hour time. So with this, I think I will close this topic. And finally, I will thank all the organizers, especially the Vignan team, HO